Welcome to the lesson activities video for sections 4.1 and 4.2. Parador is a small country consisting of 6 states, A, B, C, D, E, and F. There are 250 seats in Congress, which, according to the laws of Parador, are to be apportioned among the 6 states in proportion to their respective populations. Use Hamilton's method to apportion the congressional seats in the states. Okay, so this starts by calculating the standard divisor, which we calculate by looking at total people divided by total seats. So the units on this is going to be people per seat. How many people does it take to get a state 1 seat in Congress? So we have 12,500,000 total people divided by the number of seats we're apportioning, 250, and that comes out to 50,000 people per seat. Okay, so for every 50,000 people in a state, you get 1 seat in Congress. So then we go to this chart and we want to calculate the number of seats, the exact number of seats that each state would get by allotting them 1 seat for every 50,000 people. So you want to divide the state's population by 50,000, right? How many sets of 50,000 people do they have? So 1,646,000 divided by 50,000 is 32.92. And then 6,936,000 divided by 50,000 is 138.72. And then we just keep doing this, divide the population by the number of seats. We get 3.08, 41.82, 13.7, and 19.76. Now, if you add these up, we should get exactly 250 seats. It may be slightly off if you rounded these numbers as you wrote them down. If you wrote down the exact numbers you get in your calculator, it should come out to exactly 250. Okay, the problem now is that you can't give out a partial seat. You can't give out 9/10 of a congressional seat. It's just 1 seat. You can't give out a fraction of it. So we round all of this down in Hamilton's method. So Hamilton's method says round all of these numbers down. Everybody gets at least their lower quota, 32, 138, 3, 41, 13, and 19. That takes a little getting used to because we're not rounding using our standard rounding rules that we learned, all growing up. So we have to remember to round everything down, even 32.92. Your instinct would say round that up to 33, but we don't. We just round it down to 32. Everyone gets at least the whole number of seats that they're allotted. Okay, then we add those up and you get 246, which means we've only allotted 246 of the 250 congressional seats. There are 4 left over. So we have to decide who gets them, and we decide by looking at the fractional portion, the decimal portion of the standard quota. We're going to give another seat to the 4 states that are closest to an additional whole seat. So the largest decimal piece here looks like it's state A with 0.92, so they definitely get an extra seat. All right, then the next one would be 0.82. They get an extra seat. Then 0.76, then 0.72, and I've now given out 4 extra seats. That's all I have to give out. So C and E do not get an extra seat. We've given out the 4 extras. Now we add up the lower quota plus any surplus. So 33, 139, 3, 42, 13, and 20. And if we've done this all correctly, we add those 6 numbers together and we should get 250 seats. So this is the final apportionment. How many seats we're giving to each state. Okay, in this next example, Tasmania State University is made up of 5 different schools: agriculture, business, education, humanities, and science. A, B, E, H, and S for short. The total number of students is 12,500, and there are 250 faculty positions at TSU that are apportioned to the various schools based on those schools' enrollments. So this table shows us each school's enrollment, how many students are enrolled in each school, and we're going to use Hamilton's method to determine how many faculty positions each school gets. Okay, so we start by finding the standard divisor, which is total students divided by total faculty. Okay, so that's 12,500 divided by 250 faculty positions, and that gives you 50. And the units are students to faculty. So every 50 students in a school gets that school a faculty position. Okay, so I did not tell you in this problem what goes in these empty boxes. I'm trying to wean you off of telling you exactly how to do it. So we start with the standard quotas, which is the exact fair share for each school. So we want to see how many sets of 50 students each school has, and give them one faculty position for every set of 50. So we take the enrollment, 1,646, divide by the standard divisor, and we get 32.92. And then we do that for each state. We have 15.24, 41.62, 21.32, and 138.9. And when you add those together, we should get 250. Then next step in Hamilton's method is to round it down to the lower quota. So we have 32, 15, 41, 21, 138. We're just chopping off the decimals. And when you add those all together, you get 247, which means we have 3 more seats that we can give out. So we decide who gets the surplus by looking at the decimal portion of the standard quotas. We have 3 seats to give out, so we choose the 3 largest decimals and give them the 3 seats. So the largest one would be 0.92, they get 1. Then 0.9, then 0.62. And I've given out 3, so the remaining schools don't get an extra. And then the final apportionment, we just add the lower quota and any surplus. We have 33, 15, 42, 21, and 139. Add those 5 up, and we should get 250 seats. So this is the answer to the question. This is the final apportionment. How many faculty positions does each school get? In this last example, a corporation operates 4 beach resorts in some archipelago. The corporation plans to apportion 52 new beach umbrellas among the 4 resorts based on the number of rooms in each resort shown in the table. We want to find the apportionment of the umbrellas under Hamilton's method. So again, we always start with the standard divisor. Do this right here, standard divisor. It's, in this case, going to be the number of rooms, total number of rooms divided by the number of umbrellas. So we have 832 divided by 52, and we get 16 rooms per umbrella. So for every 16 rooms a resort has, we give them 1 umbrella. So our next step is to calculate standard quotas. We figure out how many sets of 16 rooms each resort has by dividing the number of rooms by 16. Okay, so resort A, 130 divided by 16 is 8.125. And then we do this for each resort. We get 10.625, 12.9375, and 20.3125. We add those up and you should get 52 umbrellas. Okay, the next step in Hamilton's method is to round everything down to the lower quota. So we have 8, 10, 12, and 20, and we add those up and you get 50. So we've only apportioned 50 of the 52 umbrellas that we have. So we're going to give the last two to the resorts that have the largest decimal, so that are closest to getting a whole nother umbrella. So 0.9375, that would be our largest. And then the next largest would be 0.625. So those are the two resorts that get the extra umbrella. 1, 1, and we only have 2 more to give out, so nobody else gets one. And then our final apportionment is the lower quota plus any surpluses. Okay, so this is 8, 11, 13, 20. We add those 4 up just to make sure we haven't made a mistake, and we get 52. And this is the answer, the final apportionment of how many umbrellas we give to each resort. Okay, the last question here lists some things that you like about Hamilton's method. There's no right or wrong answer here. Many things are possible. Things that I've heard in the past is that it's pretty simple to understand. It feels fair. And it's quick, pretty quick to calculate who should get what. But again, there are lots of answers here.